Okay, continuing on with our review set journey. Three functions, question two, there's three functions to integrate with respect to x. So let's do that. Alright, so 2a, we want the integral of x minus 2 on x squared dx. Now, split this fraction up to make your life easier. So it's x divided by x squared, that's 1 on x. And you've got 2 divided by x squared. I'm going to write that as 2x to the minus 2. Right. Now we can just integrate this and integrate this. If you know that the derivative, right, if you have a function log x, the derivative of that function is 1 on x. Right. So when you see 1 on x and you're integrating, your derivative is log x. The slight complication, which we don't worry about too much in maths methods, is that x needs to be greater than 0 inside of a log, right? But it's not really part of the course. I should probably write it anyway. So the integral of 1 on x is log x. The integral of this one, I'm going to be using the power law. So we keep our constant 2. We're going to add 1 to our power, and then we're going to divide by that number. Right. And we've been through this in class. We also need our plus c. So log x plus 2 on x plus c, and technically we need a domain restriction because of the log part of the function. All right, so that was 2a. We can get through b and c. The key point in that question, by the way, is split up the fraction. Right? You're not going to get logs on the test, but it's not going to hurt you to learn them. They are part of your course and you have done them in previous years. Now 2b, we've got 3x minus 4 squared. So we want the integral of 3x minus 4 squared. Now you could expand it. You don't have to, but you need to be careful when you, because this is a single power of x, I can do what I call the reverse chain rule, and I'll get the right integral. So I'll do that, I'll show you what I mean. I'm saying we'll add 1 to this power for our antiderivative. I'll then divide by that. Now if I was finding a derivative going through the chain rule, I would have gone into the inside of the function, found the derivative of the inside to be 3, and multiplied by that. So this is why I call it the reverse chain rule. I'm doing all this backwards. So instead of multiplying by 3 for finding a derivative, I'm going to be dividing by 3. You can write it in here if you like, divide by 3 there, or maybe we put it out the side, and then don't forget your c. Right, so to tidy all this up, maybe we write 1/9 3x minus 4 power of 3. Don't forget, if you're unsure, you can always check because you're good at finding derivatives, right? You say, all right, well, if I think this is my antiderivative or my integral, and I was to come along and do the chain rule, I'd be doing 3 times 1/9, right, minus 1 from the power, then I'd multiply by 3, and everything would check out. I would get back to this function. Right? So that's worked fine. You could expand it first. That will also work. You'll just get an expanded integral. Now, the last one looks good. It's where are we? You see that? I'll just write it. Okay. So 2c, they want the integral of 4 cos of 2x with respect to x. So let's go through this. Now we know that if y is sine of x, we know the derivative is cos of x. Right? This should be really well implanted into your brain, this derivatives. Now we're doing integrals, we're just going back that way, right? So, we'd say, oh well, actually let's start with 4. There's a constant 4, that stays. Now, if the derivative of sine is cos, the integral of cos is sine. Now we look at the inside of the function. Now if I was finding a derivative, at this point I would times by 2, but we're working backwards, we're going the antiderivative. So we're not going to times by 2, we're going to divide by 2. Right. Don't forget there's a constant, potentially. And to tidy all this up, we could say we've got 2 sine 2x plus c. Again, if you're not sure, you could differentiate this, and you should get back to that. Okay, so that was question 2.